Neutron stars are one of the most interesting stellar phenomena. Any more massive, and they'd create a stellar mass black hole. Neutron stars are created when a star with a mass 10 to 29 times our Sun dies. Their cores are between 1.4 and 2.16 solar masses, represented by the orange. Throughout a star's life, it fuses hydrogen, and once it runs out of hydrogen, heavier materials. Its size is kept in balance by the energy output matching the gravity pushing in. Once stars can no longer fuse materials, the energy blows away the outer layers, leaving the star's core at the center of a supernova under crushing pressure and gravity. Since gravity is increased and fusion has stopped, the star's core gets compressed into a small ball around 20 kilometers across. This is an artist's depiction of a supernova with a neutron star at the center. The red is what is left of the outer layers of the star, and the small white dot in the middle is the core, compressed into a neutron star. What is happening to the core as pressure grows is that the gravity overcomes the atomic forces. Electrons are forced into the nucleus of the atom. When protons and electrons meet, they cancel out each other's charges and become a neutron. And this happens to every proton and electron that meet, though ions will result in a few free-floating protons and electrons. The neutrons are compacted closely together, weighing 1 billion tons per sugar cube-sized part. Neutron stars have a thin crust of iron and a thin atmosphere of plasma, a few centimeters each, and are so hot that the matter in the atmosphere moves past the gas state and into the plasma state. It's theorized that at the center of neutron stars, the matter, under even more pressure, is further compacted into even smaller parts, quark matter. The quarks make up protons and neutrons in sets of 3. Known for fact, however, is that neutron stars have incredibly large magnetic fields, trillions of that of Earth's. These magnetic fields funnel charged particles to the poles of the star, where they're shot at high speeds into space. So, because of the axis of the pulsars, which is one is shown here, they tend to sweep around a lot as they spin around, like this. You can see the end of the stream moving around, and if I make it even more extreme, you can see it better, right? So when they sweep across Earth, we can detect these streams of charged particles, and we call them pulsars. And they're very regular. They spin around extremely fast, dozens or even hundreds of times per second. When neutron stars are a part of a binary system, they can feed off their partner, spinning faster and faster. One neutron star spins over 700 times per second at 24% the speed of light. Of the many different kinds of celestial bodies, neutron stars are among the extremes.